Hello. In this session we will discuss how to obtain the derivatives of inverse trigonometric functions. Usually we refer to a table at which the derivatives of the inverse trigonometric functions are given, but to give you an intuition I will derive some of them. So let's assume you would like to obtain the derivative of cosine inverse of x. So the first step, because it's easier for you to work with the usual trigonometric function rather than working with the inverse trigonometric functions, I will use cosine inverse of x as an angle. It gives me some angle y. Okay, then this equation is equivalent to cosine y equal to x. Now I can derive both sides. Derivative of cosine y equal dx by dx. By chain rule, the derivative of cosine y is equal to minus sine y. The derivative of cosine is minus sine, and by chain rule it is dy by dx, which is equal to 1. Okay, dy by dx is equal to minus 1 over sine y. So the advantage of the chain rule will give me the derivative of y in terms of x, dy by dx, which is the derivative of cosine inverse of x. So if we derive both sides, the cosine inverse of x by dx is equal to dy by dx. So the derivative of cosine inverse of x is minus 1 over sine of y. However, y is an angle that I have added, which is not given to me. Okay, so I need to define y. Okay, so I define y as cosine y equal x, which is, so this is the angle y. Okay, and this is equal, cosine is the adjacent over hypotenuse, therefore this is x over 1. So this is the adjacent x, and this is 1. Now I want to obtain sine of y. Sine of y is the opposite over hypotenuse, and the opposite by Pythagoras theorem can be obtained as 1 minus x squared. Okay, so the derivative of cosine inverse of x is equal to minus 1 over sine y, which is the opposite over hypotenuse, radical 1 minus x squared. Okay, and if we look over the second equation, it is the same, but instead of using x, we used a general function u, and of course by chain rule we should add du by dx. So now let's assume we are given to find the inverse if the function f of x is given as cosine inverse of x squared. And the objective is to obtain the derivative. You can directly refer to the table. Okay, this is the equation. So you need to find u. This is u. Okay, so u equal x squared. Okay, and from the equation we see that we need du by dx, so I can obtain du by dx as 2x. The derivative of x squared is 2x. Now I can apply the equation. This is minus 1 over radical 1 minus u squared, 1 minus u squared, and u is x squared. I substitute u by x squared, multiplied by du by dx, which is 2x. Then the answer is minus 2x over radical 1 minus x power 4. Another example, if we are given f of x equal to cosine inverse of e power x. Okay, we want to obtain the derivative f prime of x. I define u as e power x. This is u. Okay, and du by dx, the derivative of ex is ex. I substitute it in the formula, minus 1 over radical 1 minus u square, and u is ex. I substitute, multiplied by du by dx. Du by dx is given by ex. Okay, which is equal to minus ex over radical 1 minus e power 2x. Now, what if we would like to obtain the derivative of the reciprocal of trigonometric functions? Let's take secant inverse into consideration. This one. We want to prove this equation. So, if you are asked to obtain secant inverse of x, the derivative of secant inverse of x. Okay, the same thing as we did before. It's easier to treat the trigonometric functions rather than their inverses. Okay, so we assume, okay, we know that secant inverse of x at the end of the day will yield some angle y. Okay, so assume secant inverse of x is equal to y. This is equivalent to secant of y equal x. Now we want to differentiate both sides, d by dx, d by dx. On the side I will obtain the derivative of secant. If you don't know it, secant in general, secant of x, derivative of secant of x is the same as the derivative of 1 over cosine x. This is equal to, we know from calculus 2, u over v prime is u prime v minus v prime u over v square. So this is the derivative of 1, 0 multiplied by cosine is 0, minus the derivative of cosine is minus sine multiplied by 1 over cosine squared. And this is equal to sine over cosine squared. Sine over cosine is tangent of x, and 1 over cosine is secant of x. So the derivative of secant y is tangent y, secant y. I'm using this, but because we are not differentiating with respect to x, by chain rule we should add dy by dx. We differentiate the function that it hosts. Okay, which is equal, dx by dx is equal to 1. Then dy by dx is equal to 1 over tangent y secant y. Okay, again, if we are able to find dy by dx, it is the same as the derivative of secant inverse of x. Y prime is the same as, so differentiate both sides in this equation, the first assumption. So y prime is equal to secant inverse of x prime derivative. Okay, but y is something I added, so I need to define what is y, and I should remove y from my equation because I don't have y in the initial equation. Okay, so what is y? Okay, I notice that secant y is equal to x, because secant inverse of x is equal to y, and secant y equal to x. Okay, so this is the angle y, and we know the secant is 1 over cosine. Cosine is the adjacent over hypotenuse, then secant y is the hypotenuse over adjacent. Okay, so from this equation we assume that secant y equal x, and we know this is equal to hypotenuse over adjacent. So this is over 1, so the hypotenuse is x and the adjacent is 1. Okay, so I need to obtain tangent of y. Tangent of y is the opposite over adjacent. This is equal to x squared by Pythagoras theorem minus 1. So this is the radical x squared minus 1 over 1. So this is 10 over 1, which is radical x squared minus 1. And secant y by definition, it is x. Secant y, it is x. And from the triangle, it is the same. It is x over 1, the hypotenuse over the adjacent. So now I can replace tangent y with 1 over tangent y is radical x squared minus 1, and secant y is x. Okay, and we know that the hypotenuse will never be negative, so we need to have an absolute value here. Okay, and that's what it is the same as the equation given to us. Of course, this is in terms of u, and if it is in terms of u, not of x, we need to add the chain rule du by dx. By chain rule, I mean. Okay, let's do a practice. If we are given f of x equal to secant inverse of 2x, so it is f prime of x, okay, is equal to, we will be using the equation in the table. It is 1 over u, so the u is given to us as equal to x. This is u. So we just copy the formula and we replace u with 2x. And we need to obtain du by dx during the calculation. So this is equal, the derivative of 2x is 2. So f prime of x is equal to 1 over absolute of u, which is absolute 2x, radical u square, which is 2x, minus 1, multiplied by dux, which is 2. And this is equal to, so we can cancel the 2, which is equal 1 over the absolute of x, radical 4x squared minus 1. Okay, let's take another example. If f of x is equal to secant inverse of e power minus 2x, and our objective is to obtain f prime of x, the derivative of secant inverse of e power minus 2x. So our u, the function that the secant holds, is called u, which is equal to e power minus 2x, and we need to obtain the derivative of this. Du by dx is equal to the derivative of the exponential is the same, and by chain rule we multiply by the derivative of the function it holds, which is minus 2. Okay, now we just replace u with the values we obtained here. Okay, 1 over the absolute value of e power minus 2x, radical e power minus 2x squared minus 1, multiplied by du by dx, which is minus 2 e power minus 2x. We know that e power minus 2x is positive for every value of x. Okay, then this is equal to so the absolute of e power minus 2x is e power minus 2x. Then we can just cancel those terms, and then we end up with minus 2 over radical e power minus 4x minus 1. Okay, there is no electricity anymore. Okay, alright, so now you should be able to obtain the derivative of any inverse trigonometric function as we did before. You just assume the inverse trigonometric function equal to some angle y, and then you make it easier by returning back to the regular trigonometric function, and from that, you, by the advantage of chain rule, you can obtain the derivative of inverse trigonometric function. Alternatively, you can use the table, refer to the table whenever it's needed. So it's not mandatory to derive the equation every time. So for instance, let's assume you are given f of x equal cotangent, cosecant or cosine inverse of x square. Okay, and the objective is to obtain fx prime. Remember, this cotangent, you shouldn't directly refer to the inverse. You should be careful. This is the cotangent, the regular one. It is not the inverse. So you can't use like the derivative of cotangent inverse. Just be careful. Okay, it is cotangent. Okay, the function known. So cotangent of x, the derivative of it, cotangent is defined as cosine over sine. Okay, it is u prime v minus v prime u over u squared. Okay, so this is the cosine is minus sine, the derivative of cosine multiplied by sine, minus the derivative of sine is cosine multiplied by this cosine over sine squared. So minus, we take minus outside, we have sine square of x plus cosine square of x over sine square of x, which is equal to 1 over sine square of x, and minus, we have minus. 1 over sine is cosecant. Okay, and we have minus of x square. So because it's 1 over sine square, remember to put the square there. So it is, so the derivative of cotangent is minus cosecant square x. What is the derivative of this cotangent? Regardless of what the function it holds, the derivative of cotangent is cosecant of the function, whether it is x, whether it is any other function. Okay, minus cosecant square of the function it holds, which is cosine. Again, the electricity is off. Cosine inverse x square. Okay, and remember to have the chain rule. Okay, which is the derivative of cosine inverse of x squared by dx. Okay, any function, once you obtain the derivative, like in cotangent, you put the answer with respect to the function, and then you need to obtain the derivative of the function it hosts. This is the chain rule. Okay, now this is cosine inverse. Now you can refer the derivative of cosine inverse is given by this one. Okay, so what is u? Assume this is cosine inverse of u. This u is equal to x squared, right? This is u. Okay, and du by dx, we need du by dx is equal to 2x. Okay, the derivative of x squared is 2x. Now this is equal to minus cosecant square of cosine inverse of x square multiplied by the derivative of cosine inverse is minus 1 over radical 1 minus u square, 1 minus x square, this is u, okay, multiplied by du by dx, which is 2x. Okay, so this is the derivative of cosine inverse of x square. Okay, so minus multiplied by minus becomes positive, okay, and we know that the cosine inverse of x square is some angle. Let's assume this angle is equal to y. Okay, this y. Okay, so if you want to draw it, okay, this is y. So I assumed y, let me write it down here. Okay, y is equal to cosine inverse of x square. This indicates cosine y is equal to x square. And we know cosine is the adjacent over hypotenuse. So this is adjacent over hypotenuse. So the adjacent is x square and the hypotenuse is 1. Okay. Now I want to obtain the cosecant of y. The cosecant of y. Okay. So I replaced this cosine inverse of x square by y. Okay. So what is the cosecant of y? Cosecant is the reciprocal of 1 over, which is 1 over sine, and the sine is the opposite over hypotenuse. Then the cosecant is the hypotenuse over the opposite. So I need to obtain the opposite, which is by Pythagoras theorem 1 squared minus x squared, which is x power 4. Okay, so this is the length of the opposite. So the cosecant of y is hypotenuse, which is 1, over radical 1 minus x power 4. Okay, so this minus becomes plus, multiplied by minus, multiplied by 2x over radical 1 minus x power 4. Okay, remember you have square. Okay, just not to forget, this is very important. Okay, so the cosecant is 1 over radical and you have square. Okay, this becomes 1 over 1 minus x power 4 multiplied by 2x. 1 minus x power 4 radical, which is 1 minus x power 4 power half. Okay, so this is power 1 plus half, it is 3 over 2, which is equal to 2x over 1 minus x power 4, 3 over 2. So this is the final answer. Okay, this is the final answer. It is 2x over 1 minus x power 4, all radical by power 3 over 2. Now assume f of x is given as ln tan inverse of x, and you would like to obtain the derivative of f of x. So what's the derivative of ln? 1 over x. Derivative of ln of x is 1 over x, of course multiplied by chain rule, which is the derivative of the function it hosts, okay, which is 1. Then the derivative of ln of tan of inverse of x is 1 over tangent inverse of x multiplied chain rule, which is the derivative of the function it hosts. Okay, the derivative of tangent inverse of x is given as 1 over 1 plus u square. So this is 1 over tangent inverse of x multiplied by 1 over 1 plus x square. This is u x square. Okay, du by dx, the derivative of x by dx is 1. So this is equal to 1 plus x square tan inverse of x. Okay, let's take another example. Let's assume f of x is given as tan inverse ln of x. Okay, then the derivative f prime of x, the derivative of tangent inverse is 1 over 1 plus, this is u. Okay, this is u. And du by dx is equal to 1 over x. So it is 1 plus u square, which is ln x square, multiplied by du by dx. Okay. If f of x is given as ln x square plus 4 minus tangent inverse x over 2, you would like to obtain f prime of x. Okay, the derivative of ln is so the derivative of ln x square plus 4 is 1 over the function 1 over u multiplied always by the function it hosts, the derivative of the function it hosts, which is the derivative of x square plus 4 prime, minus derivative of tangent inverse of x over 2 is 1 over 1 plus u, this is u, okay, which is x square over 4. Du by dx, the derivative of x over 2 is 1 over 2, multiplied by 1 over 2, which is equal to derivative of x square plus 4 is 2x over x square plus 4 minus 2 multiplied by 1 is 2 plus x square over 4 multiplied by 2 is x square over 2. Okay, this will yield 2 over, so you get 2 common denominator, you multiply 2 over 2, so you take a common denominator, multiplied by 1 it is 2. This is will end up with 4 plus x squared. Okay, this is x squared plus 4. Right, so x plus 4 common denominator, 2x minus 2. Alright, this is the last example. If we are given f of t is equal to cosine or cotangent inverse radical t minus 1. So what is f of t? Okay, of course, in terms the derivative in terms of t, we replace x with t. Okay, the derivative of cotangent is minus 1 over 1 plus u square. So this is u, this is u, and du by dt, let me write it here, du by dt, the derivative of radical t minus 1, okay, minus 1 power half, we want to obtain its derivative. Okay, so u is radical t minus 1 and radical t minus 1 is t power minus 1 power half. Okay, this is equal to half t minus 1 power minus half. Okay, multiplied by the derivative of t minus 1, which is 1. Okay, so we have u square, which is t minus 1, multiplied by du by dt. Okay, du by dt, because the cotangent is in terms of t instead of x. So du by dt is half t minus 1 power minus half. Okay, it is minus 1 over t multiplied by half, okay, radical t minus 1, minus 1 over 2t radical t minus 1. Okay, so in this lecture we discussed the derivatives of inverse trigonometric function. We verified some of the formulas for cosine, inverse, and secant. You should be able to verify the other formulas, and you can refer to the table whenever it is needed. Thank you.